iPRSM. From design to audit to proactive management of change, iPRSM brings unprecedented accessibility, accuracy, and efficiency to pressure relief systems management. Welcome to Impact Analysis in iPRSM. iPRSM is an evergreen technology that is continually being updated to reflect the latest codes and standards as set out by regulatory or standards authorities. iPRSM Impact Analysis can tell you within minutes what effects such updates will have on your plants. It will indicate all protected systems that would be adversely affected and help track down the particular adjustments that need to be made in order to keep these systems protected and fully compliant. Impact analysis can be performed across multiple protected systems in a single unit. Analysis results can then be browsed to locate critical alerts, to search for problem system components, and to mitigate equipment deficiencies and protection inadequacies. Impact analyses can also be generated on the fly for individual protected systems. We'll look first at impact analysis for a single system. Starting on the main page, we enter a plant. Browse the protected systems within its ethylene unit, and we'll take a look at the first protected system. When more up-to-date worksheets are available, iPRSM lets us know by indicating that the worksheet a component is using is old, like the worksheet for this system. But before simply updating to the newest worksheet, we'll want to review any consequences such an update would create. And for that, we use the System Impact Analysis utility. From the Other Functions drop-down, we select Impact Analysis. We know that this system is currently fully protected, since it is in status checked. Impact Analysis will let us know in advance if the system can return directly to status checked after a worksheet update, or if the new worksheet will cause some component of the system to regress and prevent a simple recheck. We pick Analyze Impact and confirm. The analysis report displays major system components with links back to the appropriate view for each component. We see that updating worksheets for the system would mean updating also worksheets for two blocked outlet contingency scenarios. If Show All Parts is selected, we can view links to all system components, including all equipment, fittings, compound streams, and flash phases. Since iPRSM finds no critical problems with the operation, we could now go ahead and update the worksheets for the system. But before that detour, we'll go up to the unit level and look at batched analysis of multiple protected systems. Browsing the unit's 10 systems, we see 3 in red. 2 are listed as Mitigate, and 1 is Open. In fact, all 3 systems in red are currently open. Mitigate is not a true status. Mitigate means that the system has problems, cannot be checked, and is currently flagged as having its problems mitigated. 7 systems, though, are currently checked, and will want impact analysis to check to see if the new worksheets will affect their status and prevent them from being rechecked. We navigate to the unit view and select Impact Analysis. At the unit level, analyses may include the impact of changes to manufacturers' catalogs, as well as updates to worksheets. We pick Analyze Impact and confirm. iPRSM Unit Impact Analysis provides tools for searching, sorting, and mining analysis results. At the most general level, iPRSM marks each system with a null symbol if the update changes nothing, with a delta if the update will change something, with a symbol in black for systems in good order, and in red for systems with critical problems after the impact analysis operations have been completed. For systems with critical problems, where one or more component would regress as the result of an update, meaning move backward in workflow, iPRSM returns a red X along with the red delta. Looking again at the first system, iPRSM predictably returned a black delta. And as we saw when we first analyzed the system, the expanded detail view confirms that if worksheets are updated, no additional problems will be encountered. We can go ahead now and update. We go into the system. Note the required area for the controlling scenario, 2.0086 square inches. We select Update Worksheets from the Other Functions drop-down. In the Worksheet Updater, we ask iPRSM to generate an update plan, and see that equipment, stream flashes, flash phases, contingency scenarios, and the system itself all have old worksheets. We tell iPRSM to execute and update old worksheets operation, and confirm. Once the operation is complete, we return to the protected system. Worksheets are updated, but the system and its components are no longer checked. We should now work through the system, checking and upgrading the status of each component. But for this demonstration, we can simply instruct iPRSM to check the system for us. The system status changes to System OK, and we can sign off the system. The system impact analysis was correct. The new worksheet did not prevent a simple recheck. The required area for the controlling scenario remains unchanged, 2.0086 square inches. System protection remains adequate and in compliance. Back in the Unit Impact Analysis utility, we know that the displayed results are no longer completely accurate, as we have made a change to the first protected system since they were generated. A particularly handy feature of iPRSM Impact Analysis is that at any time during the process of working through the systems in a unit, we can throw old analysis results away and generate new, more current ones. Note that a black null symbol is now returned for the first system, as its worksheets have already been brought up to date. In our sample unit, each of our checked systems returned black deltas, for changed but not critical, and each of them can similarly be updated and rechecked. If we repeat the steps just illustrated for each of them, we get to impact results like these. In addition to letting us know where worksheets and catalog data can be updated without complication, Unit Impact Analysis can serve as a diagnostic tool, allowing us to isolate all systems with critical problems, for example, and view detailed analysis reports for each system in turn. Here we find an open system with a fitting diameter mismatch. Working with fittings is the subject for another video, but let's assume the decision has been made to update worksheets for this system. Again, we go into the system and to the worksheet updater. We generate an update plan and execute. Back in the system view, we find that we still cannot check the system or sign it off, as the fitting problem remains unaddressed. But we can go back into the Unit Impact Analysis utility and refresh our analysis results to include the latest changes. iPRSM returns a red null symbol for this system now. Updating its worksheets again would cause no change, as they are already up to date, but the system still has unrelated critical problems. As for the remaining critical systems with red deltas, resolving their various problems is an engineering task beyond the scope of this video, but we could, for the sake of illustration, update worksheets for each while they are under maintenance and in mitigate status, and end up with impact results like these. iPRSM Unit Impact Analysis assured us that each system that was open or in mitigate status would remain that way after an update of worksheets, and that each system that was checked could directly be rechecked without additional complication. Our unit is fully updated, with each of its protected systems restored to prior status. And so in minutes, not months, and at minimal cost in man-hours, iPRSM successfully analyzed a unit containing 10 systems, with 78 pieces of equipment and 352 fittings. The analysis referenced and checked 602 worksheets, all without you having to open a single spreadsheet. From design to audit to proactive management of change, iPRSM brings unprecedented accessibility, accuracy, and efficiency to pressure relief systems management. Brought to you by Curtiss-Wright Flow Control and Ferris Engineering.